about before. Reciprocal quotient, we talked about in the very first chapter, Pythagorean identities. I did mention in the first chapter the negative identities, that's the even and odd that we talked about when we were graphing our trig functions. Out of all the formulas we are going to see in this chapter, the only ones you have to know are ones given today. I expect you to know the reciprocal identities, which we should know which ones are reciprocals. We've talked about that from the beginning. We talked about it in graphing. I expect you to know the quotient identities, that tangent is sine divided by cosine, cotangent, then the reciprocals, cosine over sine. And I expect you to know the negative angle identities because we talked about those with graphing. Remember we said cosine and secant were even functions. And so that meant when they had a negative on the angle, we could just drop it. The other four were odd functions, so if they had a negative on their angle, it came out in front. Okay, the Pythagorean identities, these are on our formula sheet. So you do not have to memorize those. Okay, they will be given to you on any test or quiz. All right, so in all of these formulas, theta is our angle. It can be degrees, it can be radians, it doesn't matter. These are just relationships that are true. And what we're going to start doing today is practicing using these relationships to simplify and rewrite trig expressions. So this is everything on our flip book for today. What I want you to do now, keep your flip book out so you've got your formulas in front of you, but then get out some papers so we can do some problems. Does everyone have all the formulas? So all of our directions today are just going to be simplified. It will actually get a little bit easier tomorrow. So today is probably a little bit harder, partially because it's first day, partially because we haven't done anything like this before and we're trying to figure out how. What I want to do is basically just turn these things into sines and cosines and see if we can simplify it. So when I see cosecant of x, what is cosecant in terms of sine and cosine? Right, and just keep that angle, the x or theta or whatever variable I gave you. Minus, we have a cosine x times a cotangent x. What is cotangent equal to in terms of sine and cosine? Right. So we could have also changed cotangent to 1 divided by tangent, but the suggestion I gave you was just go to sines and cosines. All right, nothing cancels out, but we can multiply these. Cosine times cosine, what would that become? We have 2 of them, so it's cosine squared. Typically the square is written after the cosine just so it doesn't look like the x itself is squared. Right. If you want to add or subtract fractions, what do they have to have? Common denominator. Do we have a common denominator? Yeah, so I could combine these things into 1. 1 minus cosine squared x over sine x. All right, we are pretty close. So when you're simplifying these things, we're looking, is there anything else I can do? On the top, I have 1 minus cosine squared x. Look at all those formulas you just wrote down. Specifically, look at this one. What would happen if I subtracted my cosine over? Yeah, so 1 minus cosine squared x is sine squared x. What happens if you have a sine squared divided by a sine? Cancel out one of those signs and we just get sine x. So what that tells me is that original expression that I gave you is equivalent to just sine x. Okay, so we're just trying to manipulate these expressions and turn them into something simpler. All right. I know probably the first big thing people struggle with is when do I stop? And I promise that gets easier as we do more of them. Okay, so don't get too hung up on that yet. But right now, can you follow the steps that I did? How I got from each step to the next? Did I lose you anywhere? Okay. Let's try another one. So we're just practicing these things. How can we simplify them? All right. There are different starting points. You could go straight into sines and cosines with this. It will be a little bit ugly because you would have a fraction within a fraction. But you can do that, and that is perfectly acceptable. That's the other thing you need to kind of get used to on this is two of us may do the problem differently, but we can get to the same answer at the end. Another option. If I gave you something like 5x cubed plus 3x squared divided by x, what would you do? Okay, would you divide each of those things by x? So since my denominator is just a single term, I could split this up and say, okay, I'm going to do each one of them over the denominator. I'm going to do the 1 divided by cotangent squared x plus the cotangent squared x divided by cotangent squared x. What is 1 over cotangent squared? That means the reciprocal of cotangent, which is tangent. And since this was squared, it's just tangent squared. What is cotangent squared x divided by cotangent squared x?
Oh, you're not?
1.
You're not going to income? Where are you going?
All right. So if I have tangent squared x plus 1, do a quick check. Look at your formula sheet. Tangent squared plus 1, what's that equal to? And that's a single trig function, so I'm not going to get much simpler than that. Okay, not the only option, but one option for how to get there. Is this okay? Let's do a few more. We have to pick a place to start. What are your thoughts when you see this? FOIL. Can we start there? Sure, absolutely. All right, so if I FOIL, I get secant theta cosine theta minus secant theta sine theta plus cosecant theta cosine theta minus cosecant theta sine theta. All right, not real pretty, but we did the multiplying. What are your thoughts now? Okay. So you're thinking like factoring out some like terms? That would work. We have a lot of trig functions up here, don't we? Do you want to put everything in terms of sines and cosines first before we do any factoring and see if it helps us clean it up some? That might help a little bit. So what would I put for secant? Okay, so both of these secants turn into a 1 over cosine. What is cosecant? Sine theta. One divided by cosine times cosine. What happens to my cosines? Cancel. So this just turns into a 1. Minus. If I'm multiplying this, use multiply the tops, multiply the bottoms, so you just get minus sine theta over cosine theta. Plus, this one would be cosine theta over sine theta. Minus 1 divided by sine times sine is just 1. What happens to my 1s? Those cancel. Let's just simplify what's left. I have a negative. What's sine divided by cosine? Plus, what's cosine divided by sine? Okay, you could rewrite it as cotangent theta minus tangent theta. That would be fine as well. But we took that big, nasty expression and we simplified it down to just a couple trig functions. All right. Questions on that one?
Attention please, the following is a drill only.
All right, so this one is saying 1 minus cosine squared of negative theta. What that means is it's saying, I don't want a highlighter, 1 minus the cosine of negative theta squared. Okay, you don't have to write that, but I want you to understand what the square on the trig function means. This means 1 plus the tangent of negative theta squared. Now cosine and secant are the only even functions. That means if they have a negative on their angle, what happens to it? We just drop it. So it's just 1 minus cosine squared. Okay, tangent is odd, which means if there's a negative on the angle, what do you do with it? What happens if you have a negative squared, though? Yeah. So because of the square, that negative becomes a positive anyway. So I have 1 minus cosine squared theta over 1 plus tangent squared theta. All right, look at your identities. Is there anywhere we can go with this? What is 1 minus cosine squared going to be equal to? Sine squared. Okay, what is 1 plus tangent squared? Let's just see if anything else happens. Secant is the reciprocal of what? So I could write that as 1 over a cosine squared. How do you divide fractions? You take it times and flip that one, right? So it just turns into sine squared times cosine squared. Nothing else cancels because they weren't reciprocals of one another. So that's as simplified as we could get it. All right, I think because I'm going to stop here today and I will do my last example tomorrow.